A radian is the measure of a central angle that intercepts an arc with length equal to the radius of the circle. Okay? Within a circle, there's two different types of measurement. You have degrees, which you guys worked with back in geometry, and now there is radians. Radians and degrees, they are the two measurements within a circle. Okay? Radian measures the amount of rotation from the initial side to the terminal side of the angle. It measures its rotation. Okay? The angle with a full circle rotation measures 2 pi radians. Okay? So if I went one full rotation, yes, that would be 360 degrees, but as radians, it would be 2 pi. Okay? So radian measures the rotation. That's why, I don't know if you guys ever, if you had me, then I would have mentioned this, but that's why you need to have your mode in certain, you need to have it in a certain mode, or else it's going to do a completely different type of measurement, okay? Radian measures its amount of rotation, whereas degrees is just the angle of that particular sector, I guess you could say, okay? So there's a big difference. Now, you can go from degrees to radians and also from radians to degrees using these two formulas. If I want to go from degree to radian, I multiply by pi radian over 180, or just pi over 180. If I want to go from radian to degree, then I multiply by 180 degrees over pi radians. Okay? Literally, multiply. When you multiply, you usually multiply straight across, and then you reduce. Okay? So what is that? It says write each measure in radians in check. Okay? 20 degrees. I need to go from degrees to radians, so am I going to use option 1 or am I going to use option 2? Option 1. Okay? And think about radian, I should probably have a pi in there, so I need to make sure that I use the one that's pi. So I multiply by pi over 180. And when I multiply straight across. The same thing as saying 20 over 1. So when I multiply the top, I get what? 20 times pi. Don't multiply it through. You need no calculators for this. 20 pi over what? 180. Can I reduce 20 over 180?
Yeah.
Yes, you can. To what? What number goes into 20 and 180? 20 is going to be 1 pi over 9. And that is your radian measure for 20 degrees.
You don't need the 1, do you?
You do not need the 1. Okay? Let's do number 4. Negative 110 times what? Over. So then this gives me negative 110 pi over 180 degrees. Can I reduce that? What number goes into 110 and also 180? 10. So what's 110 divided by 10? Negative 11 pi. And then what's 180 divided by 10?
18.
Can I reduce it any further? So then there is your corresponding radian value. I want you to do the next 4, going from radian, or sorry, going from degree to radian. Number 2, you should have got 5 pi over 6. Raise your hand if you did not get 5 pi over 6.
Well, I got it. I got 15 over 18. 15 by ratings. I forgot to go lower.
Yes, keep going, because 150 and 180, 10 goes into both of those, and you can then go even smaller from there. 45, you should have got pi over 4. Anybody need me to work out pi over 4? For number 5, 315 is 7 pi over 4. Anybody need to work out 7 pi over 4? Okay? So you would have had 315 pi over 180. Since this one doesn't end in 0, it ends in a 5, we know for sure that this is divisible by 5. So 315 divided by 5 is 63. And then 180 divided by 5 is 36. Both of these are divisible by 3. So this becomes 21 over 12. And well, both of these are divisible by 3. Okay? And the last one, 320, you should have got in 16 pi over 9. Can you see that one? There you go, converting from degrees to radians. Now going the other way. If I'm trying to go from radians to degrees, and you know these are radians because, well, they all have a pi in them. That should signify that I'm dealing with radians here. To go from radians to degree, I multiply by 180 over pi. Okay? Now, depending on what number you're given in your radian, these can get really, really big. Okay? So you can use this one skill. I did the other ones one way. I'm going to do these a different way. Yes, I can multiply straight across and then continue to reduce. But like I said, these numbers can get really, really big. So what you can do is look diagonally. Doesn't 2 go into 180? How? 90. So this reduces to a 1. This turns into a 90. Is there anything that goes into 3 pi and pi? So I can cancel out my pi. Now I can multiply straight across. Negative 3 times 90 is, and 1 times 1 is, and there's my degree, negative 270 degrees. I would have gotten the same thing if I multiplied straight across. I just would have been dealing with a bigger number. 3 times 180, which is what, about 40, divided by 2. But I still would get the same answer. Let's look down here at number 10. I'm going to multiply by 180 over pi. Yes, I can multiply straight across, but now I'm dealing with, again, some super big numbers. And if this was a non-calculator question, then we would kind of be a little screwed, okay? 5, does 5 go into 180?
Yes.
How many times? And 8 pi and pi? My pi's cancel out. That's one thing, okay? If I'm trying to go from radians to degree, I should have no more pi's. Okay, so that's how you, if you forget which one goes with which, just think about that. I should have no more pi's when I'm trying to go to degrees. So now what's 8 times 36? Now use your calculator. And then 1 times 1 is, there you go, 288 degrees. This will be the same thing you would have gotten if you do 8 pi times 180 over 5 times pi. Take a minute, do the next 4. All right, for number 8, 300 degrees. Anybody need to see that one work out? Okay. Let's see, pi over 12. What you got to do for pi over 12? 15 degrees. Good. Negative 7 pi over 6. We're going in the clockwise direction. Negative 7 pi over 6. Did you get negative? Don't tell me. Negative 210? And let's see, 9 pi over 2. That's definitely bigger than 2 pi. So we are looking at, don't you dare say anything. Let's see, that's 1, 2, 2 pi, 4 pi, 8 pi. That might tell me. It's like 800. Now, the reason why I'm able to do ones like 8 and 11 and 7, or even on the other ones like 150 and 315, because those are actual radians and degrees on your unit circle. Okay, so like I said, if we're lucky, we'll give some time so we can actually go more into like those quadrants of the unit circle, and then you'll be able to see exactly, where these angles and these radians are coming from. Okay. So, any questions on terminal angles, converting from degrees to radians or radians to degrees before we move on? So this was your first introduction into